Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. You are welcome once again to our class, which promises to be very interesting. Before I go on, I wish to appreciate you, acknowledge your steadfastness so far in staying tuned to this station, because without you, we will not be here. Today, we are looking at a new topic entirely. This topic cuts across various levels in secondary school, starting from the GSS3 level and up to SS1, 2, and 3. Interestingly, this topic also cuts across both general mathematics and further mathematics and is quadratic equation. What exactly is quadratic equation? Before I go further, we can add what is called quadratic expression. It's very important to distinguish between an expression and an equation. As the name applies, an expression is simply a mathematical statement, whereas an expression is a mathematical statement with an equality sign. So the distinguishing difference between an equation and an expression is the presence of equality in an equation and the absence of same in an expression. Today, we are looking at the standard form of a quadratic equation, the various methods available to solve a quadratic equation problem at the ordinary level, that's O level, and of course, the main focus of the lesson would be in taking one method, which is factorization method. So I enjoin you to sit back and let's dive in. To start with, the standard quadratic equation is given usually as ax squared plus bx plus c, with the proviso that a must not be equal to 0. Because if a equals to 0, automatically 0 times x squared means 0. Hence, we reduce this equation to a mere linear equation. Hence, a can assume any value but 0. What then are the methods of solving quadratic equation? As I said in the intro, we have 4 methods. We'll be looking at the first of them, factorization method. Then we'll be looking at completing the square method. Then we have the general formula method. General formula method, which in the days past, people call it almighty formula. And lastly, there is, of course, the graphical method. These are all methods for solving a standard quadratic equation. Again, factorization method, completing the square method, the general formula or just formula method, or at times it's called quadratic formula method. And lastly, you have the graphical method. So today, we are going to be focusing on the factorization method and how does it operate. Interestingly, all these methods, when we use them, we are going to necessarily get the same answer. Now, before I go further, let me explain the concept of the solutions of a quadratic equation. Or let me take us back to the elementary linear equation. The clue or the idea is that the degree or the power, which is the highest degree of an equation, tells us how many solutions or answers we're going to have. Prior to now, when we solve linear equations in just one degree, we're going to have just one answer. The best we can have is when we have 2 variables, we're going to have 2 answers. That is maybe simultaneous linear equation. However, if we are talking about one variable, the degree will tell us how many answers we are going to have. So in linear equations, we usually have one answer. So expectedly, for a quadratic equation whereby you have degree 2, we're going to have 2 answers. After having said that, let's delve into the topic for the day really, which is factorization method of solving quadratic equation. I must say before I go in further that is not all questions that necessarily can be solved by this method. Not all questions, meaning there are some questions that can never be solved by factorization method. However, there's a need to know a form of test beforehand, before proceeding. So if we test that question by what I'm going to give you now, and it works, that means we can go ahead and adopt this method. And that is what I call the test of factorizability. So you have b squared minus 4ac. If you get a perfect square, then that means that question can be factorized. This is what I call the test for factorizability. We know what our A, B, C are. A is the coefficient of x squared, B is the coefficient of x, and C is the constant. It has no x attached whatsoever. So let's take some questions now. Solve by factorization method. Again, I must emphasize here that if you're writing an examination theory particularly, and the instruction comes as solved by a particular method, as a candidate, you are necessarily expected to stick to the instruction by solving using that method. If, for example, you ask to solve by factorization method, and you think that it's convenient for you to use completing the square, I'm afraid you're going to get no score, grade 0. You're going to get the answer quite right. But because you chose not to follow the instruction, by sticking to the method given to you, you'll be marked as 0. So you must learn each method as it were. So number 1, we have, let's say, y squared minus 8y and plus 15 equals 0. Let's take this for example to start with. Now, if you have to solve this by factorization method, how does the method work out? There are some procedures we follow here. Now, the coefficient of y squared is 1 in this case. For y is minus 8 and the constant is c, which is 15. So what you're going to do is to multiply the coefficient of y squared, which is 1, with the constant. So I'm going to say 1 times, the constant is plus 15. So I'm going to have plus 15 as my answer, as the product. The next step is, mentally, you think of the factors of 15 that at the same time gives you minus 8. Of course, plus 15 has several factors. We've got minus 1, we've got minus 15, we've got plus 1, we've got plus 15, which will both give us plus 15 when you multiply. However, none of those two factors, set of factors, give us minus 8. Hence, we go for others, and these are minus 3 and minus 5. Because minus 3 times minus 5 is plus 15 on one hand. Then minus 3 plus minus 5 gives minus 8. Hence, the aim is to break down this middle value here, minus 8y, into these two factors. We have minus 3y, then minus 5y. Then, of course, plus 15. So we are only altering the middle value. It's immaterial which one comes first. I could have as well written minus 5y before minus 3y. It doesn't matter really. Now we've got 4 terms separately now. All we need to do is to pair them. We pair them in 2's and we factorize them. So for y squared minus 3y, the common value there is y. Then I'm going to have here y minus 3. I'm done with this part. Then for this minus 5y and plus 15, the common term there is minus 5. Then necessarily, I am going to have the same content in the two brackets. Necessarily. So at this level, the common term to these two is still y minus 3. Then what's left outside the bracket are y and then minus 5 equals to 0. So at this stage, we have a product of two terms being 0. So naturally, in mathematics, when you multiply two terms to give 0, either of them or both will be 0. So we say by interpretation, either y minus 3 is 0 or y minus 5 is also 0. We then conclude that y is equal to 3 or y equals to 5. And that is the end of the solution, meaning that the values 3 and 5 will satisfy this equation. They are the solution, or it's also called root. And the good way of testing is when you substitute this value 3 and 5 respectively into this equation, you must necessarily get 0. That's a way of checking if you are right or wrong. I believe that's quite explanatory. Let's take our very second question. What happens when we don't have 1 as a coefficient here? That's the next example. So we are still going to solve by factorization method. Let's say we have p squared minus 5p is equals to 12. Now, sorry, 2p squared minus 5p is equals to 12. So there's no much difference. However, the first thing we have to do is to write this question in the standard form. Standard form is always having everything on one side equals to 0. Hence, the first thing is to bring the 12 to the other side. Minus 12 equals 0. It's not properly in the standard form. Then we go as before. The coefficient of p squared is 2. I'm going to say 2 times the constant is minus 12. Minus 12. That gives us minus 24. So we now break down into two factors such that the product remains minus 24, but the sum remains minus 5. And that's going to become minus 8 and plus 3. You must take cognizance of the signs, minus 8 and plus 3. Because minus 8 plus 3 gives minus 5. And minus 8 times plus 3 gives minus 24. So every other thing remains except the middle value, which we change to what? Minus 8p plus 3p, then minus 12 equals 0. Then as before, we pair up and we factorize respectively. So what's common here? We have 2p common, then p minus 4 plus what's common here? 3. And as I said earlier on, necessarily the contents of the bracket will be the same. Hence, we have what's here? P minus 4 and then 2p plus 3 equals 0. I believe it's quite straightforward. And lastly, again, we're going to have p minus 4 being 0 or 2p plus 3 also being 0. And to complete that, p equals to 4 or p equals to minus 3 over 2. And again, those are the solutions or roots of this quadratic equation. And that's been the factorization method. I believe you found this class quite interesting, as I did. However, I did mention something here about b squared minus 4ac being perfect square. So how would you have known before delving in? I could have just tested by saying, okay, b is minus 5 here. That's the coefficient. B squared minus 4. What's a? A is 2. And what is c? C is minus 12. So that's going to become 25. Then plus 4 times 2 is 8. And 8 times 12 is 96. So when you add this up, you're going to have 121, which is a perfect square. So that's an after though. So ideally, you're meant to have tested this before delving into the question. Once you test this and you get a perfect square here, definitely the question is factorizable and you are free to go ahead and factorize. So the lesson today has been factorization method of solving a quadratic equation. And I did say that a way of finding out if a question is indeed factorizable is to try this test of factorizability. When you have b squared minus 4ac being equivalent to a perfect square as a value, that means you can go ahead and solve by factorization method. If you get an answer other than a perfect square, then don't bother wasting time on that method. It's not applicable. And I think you find this class quite interesting and enlightening, and most importantly, fun. If you do, please try to subscribe, share, and of course, tune in your notification button so that you'll be the first to know when our next video is dropped. Thank you and stay blessed.